Right now, beneath the surface of global politics, a silent war is being fought. It's not about land, oil, or even AI data centers. It's a race for a material so powerful it could instantly shift the global balance of power. Some call it the holy grail of modern science. If won, it will spark a global energy revolution, unlock limitless clean power, enable silent stealth submarines, and supercharged quantum computers. This is the superconductor race, an elite high-stake geopolitical competition compared by experts to the nuclear race of the 20th century. As we navigate in 2026, the battle lines are officially being drawn. To understand why nations are throwing billions of dollars at this, we have to look at the flaw hidden inside all modern technology: electrical resistance. Right now, when electricity moves through regular copper wires, electrons slam into atoms. This friction generates heat, wasting up to 10% of all electricity generated on Earth. But what if they could eliminate that friction entirely? Here enters the superconductor. At ultra-low temperature, electrons undergo a bizarre quantum transformation. They form at what physicists call copper pairs, moving in perfect harmony with zero resistance. No friction, no heat, absolute flawless efficiency. They don't just conduct electricity, they create incredibly powerful magnetic fields that can literally expel magnetism, allowing objects to levitate. Historically, traditional superconductors only work near absolute zero, around minus 269 degrees Celsius. To keep them that cold, you need complex infrastructure and incredibly expensive liquid helium. In the 1980s, scientists discovered high temperature superconductors, or HTS. But high temperature in physics is a relative term. It meant minus 196 degrees Celsius. Better because we can use cheaper liquid nitrogen, but still widely impractical for an everyday smartphone or a local power grid. The ultimate dream is a material that acts as a superconductor at room temperature and normal atmospheric pressure. The hunger for this breakthrough is so intense that when researchers in South Korea claimed a material called LK99 was a room temperature superconductor, the internet completely melted down. Global stock shifted, labs worldwide rushed to replicate it. Ultimately, the LK99 claims failed to hold up under scientific scrutiny. But the frenzy did something historic. It injected millions of dollars of fresh funding into the field and triggered an aggressive AI-driven rush to find the real thing. As we look at the global landscape today, the race has split into three distinct fronts. And contrary to what you might think, there isn't just one country winning. Different superpowers dominate different arenas. First up, mass manufacturing. And here, China is the undisputed heavyweight. China dominates the production of REBCO, rare earth barium copper oxide tapes. These are the high temperature superconductor tapes vital for next generation hardware. By leveraging its absolute monopoly on rare earth supply chain and heavy state funding, Chinese companies are scaling up to produce an astonishing 20,000 km of HTS tape per year by 2027. It's the same playbook China used to dominate solar panels and EV batteries. But let's flip the script to advanced application and quantum computing. The United States holds the crown. American tech giants dominate the integration of superconducting circuits into quantum computing quips. Furthermore, the US excels in high-field superconducting magnets, recently delivering key modules of ITER, the world's largest nuclear fusion project. This single US-built magnet system stands 18 meters tall, weighs 10,000 tons and generates a magnetic field strong enough to lift an aircraft carrier. Meanwhile, Japan remains the undisputed king of precision engineering, producing the world's highest quality of ultra-pure superconductor materials, while Europe drives massive multinational fusion consortiums. But let's talk about the part countries don't like to discuss publicly: the military race. Why are defense departments so obsessed with superconductors? Because they fundamentally rewrite the laws of warfare. Imagine naval warfare where submarines don't use noisy mechanical gears. Superconductor motors are incredibly small, widely powerful and virtually silent, offering a total naval stealth. Consider weapon system now. Superconductors store and transfer massive bursts of electricity instantly. This makes hypersonic electromagnetic railguns and high-energy directed laser weapons a terrifying practical reality on the battlefield. Add in ultra-sensitive quantum radar that can spot stealth aircraft, and you quickly realize whoever controls the superconductor supply chain controls the future of global defense. The current reality of the world is clear. We have mastered the high-temperature superconductor for fusion magnets, quantum computers, and heavy industries. But the true holy grail of stable, low-temperature, normal pressure material remains undiscovered. If or when a country unlocks that final door, it will spark a revolution. As disruptive as artificial intelligence, as structural as semiconductor, and as strategic as nuclear energy. The race is far from over, and the prize isn't just a trophy, it's the key to the next century of human civilization. Which country do you think will cross the finish line first? Do let us know your thoughts in the comments. Don't forget to like and subscribe for more such deep dives into the tech shaping our future. I'm Shreya signing off.